So once again, we want to graph the sketch the graph of the function x squared plus x minus 1. As before, right? I can look for the x-intercept, which always exists, by replacing x by 0. Gives me the constant term minus 1. So essentially, 0 minus 1 is the y-intercept. X-intercepts. Now at this point, right, I want to solve this equation, but let's take a look now at if I try the AC, the AC method, right? I'm looking for a product, two numbers that have a product of minus 1, sum of 1. That's, at least with integers, that's not possible. So this is where I need to rely on the quadratic formula. So factoring is not possible here. Maybe it can't be factored, that's the other thing. So the quadratic formula will tell me that too. So if I don't have any roots, if I have a negative underneath my square root in the quadratic formula, there aren't any solutions to that, which means that the graph of my function lies completely above the x-axis or completely below it. What's the quadratic formula again? X is, when you're trying to solve ax squared plus bx plus c equals 0, it's minus b plus or minus square root of, can't even remember myself, b squared minus 4ac over 2a. So if b squared minus 4ac, like I said, turns out to be a negative number, you don't have any roots. If you don't have any roots, right, you don't have any x-intercept. No x-intercept means the graph would be like that or like that. But if you do have roots, that means it's going to cross the x-axis. So let's see here. So x is minus b, so minus 1, plus or minus square root of b squared, so 1 squared, minus 4 times a, which is 1, times c. C is minus 1 here. Careful, huh? You have to, in your head, you should sort of rewrite the expression by putting plus signs everywhere. So your a, your b, your c will incorporate the negative sign if there's a subtraction going on. 2a is 2 times 1. Okay, so let's look at that. This is plus or minus 1 minus 4. 1 minus 4 exactly. So 1 plus 4 over 2. So this is minus 1 plus or minus root of 5 over 2. So I do have I have two roots here. So x is either minus 1 plus root 5 over 2. Or x is minus 1 plus minus root 5 over 2. Eventually we'll need to place our x-intercepts along the x-axis, so it's kind of nice to know what this corresponds to numerically. So the minus 1 plus root 5, that's actually almost 0.61. This one is approximately minus 1.61. Okay. So the x-intercepts here are minus 1 plus root 5 over 2, 0, and the other one is minus 1 minus root 5 over 2, 0. What else? We need the vertex of our parabola, which is halfway between our x-intercepts. But notice something, right? The x-intercepts are what are they? They're minus 1 plus or minus root 5 over 2. There's a good way to write this. You can write this as minus a half plus or minus root of 5 over 2. So essentially, if this is minus a half, one is root of 5 over 2 to the right, and the other is root of 5 over 2 to the left. Right? Either you subtract root of 5 over 2 or you add it. But what's in the middle is the minus a half. So what's interesting with the quadratic formula is that If you look at this part, that's the middle. Okay? And this is also interesting. If you look at the formula up there, minus b over 2a, that's going to be always the coordinate of your, the x-coordinate of your vertex. Okay? So maybe actually we can write that down. That's kind of an interesting thing. And this is true for every parabola. So the x-coordinates, in your book, they tell you, they give you the formula without any explanation. That's a possible explanation. The x-coordinate is minus b over 2a. But like I said, you don't need to remember that by heart. You just need to look at, see the part that's not affected by the plus or minus in the quadratic formula. And here it's just minus a half. So, and then of course we need the y-coordinate of that. So I need to calculate f of minus a half. Okay, I'll skip you the work, but it's going to be minus 5/4. Okay. All right, so we're minus 5/4 is what? It's minus 1 plus minus 1/4, so it's minus 1.25. Okay, if we need to have a numerical value to help us better identify where that's going to lie on our graph. So the vertex is minus a half minus 5/4. And now we're ready to sketch our, well, I didn't look at concavity, but the coefficient of x squared is positive. So a is actually 1, which is positive, which means it's going to be concave up. Okay, so let's draw this. What do we need? So the x-intercepts, right, they are, this is what I look at first because I know the vertex is going to be in the middle. So I adjust for the scaling along the x-axis using the x-intercepts. So it's minus 1.61. So I'm okay if I'm go by steps of minus of 1 like that. Maybe 1, 2 here like that. So one is at 0.61, that's roughly here. The other one's at minus 1.61, roughly there. Where's my vertex? My vertex is minus a half. Minus a half will be right, just a little bit. Yeah, will be somewhere here, right? Exactly here. And minus 5/4. So maybe I'll go again by steps of 1 like this. This would be minus 1, minus 2. Minus 5/4 is minus 1.25, so a fourth of, okay, here we go. And what am I missing? I feel I'm missing the y-intercept. We said it's 0 minus 1. So it goes through here. Okay, so let's draw our parabola. So again, make it flat at the vertex. There we go, like that. And then we can indicate the coordinates of our points. So this is here minus 0 minus 1. This one is minus 1 plus root 5 over 2, 0. This is minus 1 minus root 5 over 2, 0. What's the vertex? Minus a half minus 5/4. And that's it.